At dawn, one engineer changed everything. Part 1. Cold Open, Portland, Oregon. Kaiser's shipyard. September 1941. Early morning. An unfinished transport hull sits on the slipway. Workers stand by cold metal. Riveters look at blueprints. Their faces are grim. By calculations, this ship will be ready in 8 months, maybe 9. If materials arrive on time, if there are no delays. In the Atlantic, German submarines sink ships every day, every night. Tonnage goes to the bottom faster than it's built. The numbers don't add up. Civilian engineer Henry Kaiser stands at the slipway's edge. He looks at the hull, he looks at the calendar, he counts the days. 8 months for one ship. The Allies need 100 ships. They need 500. They need 1,000. The mathematics of war are simple and brutal. If they build the old way, the war is lost. If they don't change the method, tonnage can't be replaced. The enemy wins by arithmetic. Kaiser looks at the workers. He looks at the unfinished hull. An idea forms in his mind. An idea everyone will call insane. He's going to build an ocean-going ship in days, not months, days, and it'll change everything. Part 2. Context. By fall of 1941, the Battle of the Atlantic rages. German U-boats hunt convoys. Every month, hundreds of thousands of tons go down. Britain suffocates without supply. The United States is just entering the war. But it's already clear what's needed. Ships. Hundreds of transport vessels. Thousands. The problem is, shipbuilding has always been slow craft. A ship was built from keel to mast over months. Riveters joined metal plates one by one. Every seam required time. Traditional shipyards worked like medieval workshops. Master shipbuilders knew their trade. They passed skills down through generations. But their methods don't fit industrial-scale warfare. Britain tried increasing production, built new yards, hired more workers, but speed stayed the same. The U.S. Maritime Commission announced an emergency shipbuilding program. They needed simple, cheap, fast-to-produce transports. The project got the name Liberty Ship. The design was maximally simplified. Obsolete steam engine instead of modern turbines. Simple hull forms. Minimum complex elements. But even the simplified design took time. 8 months per ship was considered normal. 6 months was an excellent result. At those rates, the program couldn't keep up with losses. Henry Kaiser came to shipbuilding from outside. He'd built dams and bridges. Never built ships. Marine engineers looked at him with distrust, but Kaiser knew something else. He knew mass production. He'd seen how Henry Ford built cars on assembly lines. He'd seen how simple methods multiply results. He proposed applying these principles to shipbuilding. Break the ship into sections. Build sections in parallel in shops. Then weld them on the slipway. Traditional shipbuilders were horrified. You can't assemble a ship like a car. It's not an assembly line. It's a complex structure requiring craftsmanship. Welding instead of riveting seemed dangerous. Welded seams could crack in waves. The hull could split in storms. The risk was enormous. But Kaiser insisted. He built huge shops next to the slipways. He divided blueprints into sections. Each section was a separate module. Bow section in one shop. Stern in another. Midsection in a third. Superstructure in a fourth. Workers no longer waited for neighbors to finish their section. Everyone worked simultaneously, in parallel, independently. When sections were ready, they moved to the slipway. Giant cranes lifted multi-ton blocks. Welders joined them in days. What used to take months compressed to weeks. The Maritime Commission had doubts. Military engineers demanded tests. Shipbuilders' unions protested the simplification. But time wouldn't wait. In the Atlantic, ships were sinking. tens of thousands of tons lay on the bottom. British cities starved. War's arithmetic demanded a solution. Kaiser got a contract for 30 Liberty ships. The first yard started work in spring of 1941. Methods were refined on the fly. Mistakes got fixed immediately. But even with new methods, everything went slower than needed. The first ships took 5 to 6 months. That was better than the traditional 8, but not good enough. Kaiser understood they needed to go faster, radically faster, impossibly faster, and he knew how to do it. Part 3. Rising pressure. Spring of 1942 brought catastrophe. Germany launched Operation Drumbeat off American shores. U-boats hunted right off the coast. Tankers burned in sight of New York. In the first months, over 1 million tons were sunk. The ship shortage was catastrophic. Every sunken transport struck its supply. Every month, the deficit grew. Kaiser looked at production charts. His yards built faster than others, but not fast enough. Even cutting time to 4 months, they couldn't cover losses. There weren't enough workers. Experienced shipbuilders joined the fleet. Novices came to the yards without experience. Women, old men, yesterday's farmers. There was no time to train them in traditional craft. Simple operations were needed. Operations that could be taught in a week. Operations anyone could do. Kaiser broke every operation into simplest steps. One person welds one type of seam. Another installs one type of fastener. A third paints one section. Specialization reached absurdity, but it worked. An untrained worker became effective in days. Productivity grew. Materials were also scarce. Steel went to tanks and planes. Engines waited for months. Every delay stopped the slipway. Kaiser started building his own factories. Foundry shops next to yards. Component production on site. Shortened logistics chains. But time remained the main problem. Even 4 months was too long. Germany sank ships faster than they were built. The mathematics still didn't work. Kaiser gathered engineers. He asked directly, could they build even faster? How fast was theoretically possible? Engineers calculated. They looked at blueprints. They searched for bottlenecks. They broke down every process by minutes. Slipway assembly took the most time. That's where sections waited for cranes. Welders waited for sections. Delays ate up days. Kaiser proposed a radical solution. Increase the number of slipways. Build several ships in parallel. Organize a real assembly line. But even that didn't fully solve the problem. The assembly itself needed acceleration. Make it maximally fast. Push it to the limit. In summer of 1942, Kaiser announced an internal competition. Which yard could build a Liberty ship fastest? Winners get bonuses. Losers get shame. Teams started finding ways to save hours. Pre-fitting sections in shops. Precise marking of weld seams. Materials prepared in advance at workstations. Assembly time started shrinking. 3 months, 2.5, 2 months. But Kaiser wanted more. He wanted to prove the impossible was possible. He wanted to show America's industrial might would break any blockade. He wanted to build a ship in weeks. In fall, they started preparing a record attempt. They chose the best crew. They selected the best craftsmen. They prepared all sections in advance. Everything had to be perfect. Not one delay, not one mistake. Work day and night without pause. But doubts remained. Could you even build an ocean-going ship in days? Would it survive a storm? Wouldn't it fall apart on the first wave? Engineers checked calculations. They tested weld seams for strength. They modeled the structure again and again. Theoretically, everything should work. But between theory and practice lay an abyss. One bad seam and the hull cracks. One rush job and men die at sea. The responsibility was monstrous. Kaiser understood the risk. He understood if the ship sank, they'd blame him for crew deaths. He understood he was gambling his reputation. But he also understood without risk, the war couldn't be won. In November 1942, everything was ready. Sections stood by the slipway. Cranes took positions. Teams waited for the signal. Kaiser gave the order to begin. Stopwatches clicked on. Work started. The fastest ship construction in history. Part 4. The Decision. November 12, 1942. Yard number 2 in Richmond, California. 7 in the morning. Whistles blast over the slipway. The first section's already in place. The keel was laid the day before. Welders stand with electrodes ready. Cranes swing their booms. Henry Kaiser stands on the viewing platform. Journalists with notepads stand beside him. Photographers with cameras. Everyone waits. He'd made the announcement a week ago. His yard would build a Liberty ship in 7 days. Many didn't believe it. They called it a publicity stunt. But Kaiser was serious. He'd prepared every detail. He'd rehearsed every movement. He'd turned the slipway into a theater of precision. The bow section, weighing hundreds of tons, slowly rises on the crane. Operators control cables with millimeter precision. The section hangs above the keel. The descent begins. Workers below catch the section with cables. They guide it into place. They mate it with the keel beam. Welders rush to the seam. Sparks fly in all directions. Metal melts and joins. The seam crawls along the joint. One welder replaces another without pause. An hour later, they lift the midsection, the heaviest one, the most complex, the ship's heart. Cranes work in sync. 4 booms hold the section. Any mistake and it falls. But the operators know their business. The section settles into place with a dull thud. The slipway shakes, the guides creak. Welders are already there. By evening of the first day, the hull's a third assembled. 3 main sections stand. Bow, midships, stern. The ship's skeleton is visible. The night shift continues without stopping. Floodlights bathe the slipway in light. Welding arcs flash like stars. Work doesn't stop for a minute. On the second day, they start installing decks. Huge steel sheets arrive by crane. They're laid on crossbeams. They're welded along the perimeter. Every operation is calculated. Every movement is practiced. Teams work as a single mechanism. No extra words, no extra actions. By the third day, the hull's closed. The superstructure rises onto the deck. Deckhouse, bridge, stacks. The ship takes shape. Fourth day, internal systems. Piping, electrical, pumps. Everything goes in parallel. One team doesn't interfere with another. Fifth day, main power plant. The steam engine was assembled in the shop beforehand. Now they install it whole. Cranes lower the engine into the machinery space. Engineers connect shafts, mechanics tighten bolts. Stokers prepare boilers. The system comes alive. Sixth day, finishing and testing. They paint the hull. They mount lifeboats. They check every system. Kaiser hasn't slept for 2 days straight. He walks the slipway. He checks seams. He talks with foremen. He knows more than one ship is at stake. The method's reputation is at stake. If this ship goes to sea and sinks, they'll shut down the program. If it holds, the door opens for thousands more. Seventh day, final checks. Ballast cargo for stability. Fuel in tanks. Evening of November 12th, the ship's ready. From first section to final paint, exactly 168 hours passed. 7 days. An ocean-going vessel assembled like a toy. Kaiser stands on the new ship's deck. The hull of SS Robert E. Peary smells of fresh paint. The decks aren't worn yet. Everything's new, untouched. He gives the order, launch the ship, run sea trials, prove it's not just a structure, but a real vessel. The slipway tilts. The ship starts sliding. It picks up speed. It hits the water with an enormous splash. Thousands of workers shout and wave. They've done the impossible. They've built a ship in a week. They've changed the rules of the game. Part 5. Immediate Aftermath. S. Robert E. Peary went to sea 3 days later. Trials began with machinery checks. The steam plant ran smoothly. No vibrations, no leaks. The ship reached its rated speed, 11 knots. Not fast for a modern liner, but enough for a transport. They tested maneuverability, turns at different speeds, rudder operation, stability in waves. Everything worked. Welded seams held pressure. The hull didn't creak. The ship behaved as it should. The Maritime Commission sent inspectors. They checked every compartment. They tapped on bulkheads. They examined seams with magnifying glasses. They looked for signs of haste, signs of defects, weak points. But they found little. The inspection report was cautious. The ship meets standards, approved for service, can join a convoy. News spread through every yard in the country. Kaiser built a Liberty ship in 7 days. The ship passed trials. The method works. Other shipbuilders didn't believe it at first. They thought it was propaganda, a specially prepared demonstration project, impossible to repeat. But Kaiser repeated it. A month later, his yards launched another ship, in 10 days, then in 14. Speed became the norm. What seemed a record became standard. Kaiser's yards produced ships faster than German U-boats sank them. War's arithmetic started changing. The Maritime Commission revised plans. They didn't order hundreds of Liberty ships. They ordered thousands. 2,500 ships over 3 years. Other yards started adopting Kaiser's methods. Sectional assembly, welding instead of riveting, parallel production. Shipbuilders' unions protested. They said this simplification killed craftsmanship, that welded ships were unreliable, that Kaiser sacrificed quality for speed. Indeed, there were problems. Some early Liberty ships developed hull cracks. Welded seams split in cold water. Several ships broke in half in storms. Engineers studied the causes. The problem was in the steel type. In low temperatures, it became brittle. Welded seams concentrated stress. They changed the steel composition. They added expansion joints. They reinforced critical zones. The problem was solved. By mid-1943, Liberty ships were built en masse. Every 3 days, a new vessel left the slipways. Sometimes more often. The assembly line ran at full capacity. The Atlantic filled with American transports. Convoys grew larger. British supply stabilized. Cargo flowed in continuous stream. German U-boats still hunted, still sank ships, but they couldn't keep up with production anymore. For every sunk transport, 3 new ones were built. The Battle of the Atlantic slowly turned. Not in one day, not in one battle, but inexorably. By the end of 1943, the Allies built more tonnage than they lost for the first time. The curves on charts intersected. Production exceeded losses. The blockade broke. Liberty ships carried everything: tanks and planes, ammunition and food, troops and equipment. They enabled the Sicily landing, the Italy landing, the Normandy landing. Without them, there'd be no second front. Every major operation required hundreds of transports. Only Liberty ships could provide such numbers. Only mass production enabled the scale. Only Kaiser's method made it possible. By war's end, they'd built 2,710 Liberty ships. Most survived until hostilities ended. They transported millions of tons of cargo, millions of soldiers. Part 6. Echo. The war ended, but Liberty ships kept working. They carried troops home. They carried humanitarian aid to destroyed Europe. They restored world trade. Many served for decades after the war. They were sold to private companies. converted for different cargo. They sailed all the world's oceans. Kaiser's method changed shipbuilding forever. Sectional assembly became standard. Welding completely replaced riveting. Mass production of ships became reality. Modern yards build by the same principles. Modular construction, parallel production of sections, fast slipway assembly. Kaiser proved a ship is an industrial product, not a shipwright's work of art, but the result of precise planning and organization. Engineering, not mysticism. After the war, he built an empire, steel mills, aluminum plants, automotive facilities. But Liberty ships remained his greatest achievement. They won a battle that weapons couldn't win. The battle of production, the battle of economics. Germany didn't lose only on battlefields. It lost in shipyards and factories. Its U-boats sank ships. But America built them faster. One engineer with an assembly line idea changed war's balance. Not a general, not an admiral. A civilian builder with dam construction experience. His decision to assemble a ship like a car seemed absurd. Professionals laughed. Experts said it was impossible. But he proved otherwise. SS Robert E. Peary served until 1963. 21 years after launching, it sailed hundreds of thousands of miles. It survived storms and peacetime. The ship built in 7 days proved its strength. Welded seams held. Simplified construction worked. Speed didn't kill quality. Today, several Liberty ships are preserved as museums. They stand in harbors. Tourists walk their decks. They read plaques about the war. But few understand their real significance. They're not just old ships. They're symbols of how industry wins wars, how production decides conflicts' outcomes. Henry Kaiser died in 1967. His empire dissolved after his death. Companies divided and sold, the name nearly forgotten, but the method remained. Factories worldwide build ships in weeks. They assemble them from sections. They use welding and standardization. It all started on a slipway in Richmond, with one man's decision to try the impossible, with 7 days of continuous work, with a ship that shouldn't have succeeded. The Atlantic holds hundreds of sunken vessels. German U-boats sent them to the bottom. But for every one sunk, new ones were built, faster than the enemy could sink them. This was a war of arithmetic, and an engineer with an assembly line idea won it.